So it was with the Trent water ingestion test. The certification requirement is that the equivalent of 33,000 gallons of water an hour are sprayed through the engine without any loss of rated thrust. It was no surprise to Rolls-Royce that the Trent passed this test. The hard work of analysis, design and manufacture had already been done. In the cold start test, the engine is sprayed with atomized liquid nitrogen until it's frozen, along with its oil and fuel supplies, right down to -40 centigrade or lower. The engine then has to start within 90 seconds. Low operating temperatures also present problems at altitude. Tests replicate altitude conditions by controlling the pressure within the test chamber. The engine then has to demonstrate restarts, both windmilling and motor-assisted, depending on the effective altitude.
Thank you.
It must also prove an ability to cope with icing. Yet more tests are designed to replicate, or rather exceed, the severe operating conditions to which the engine will be subjected, day after day, year after year.
50,000.
Thrust must be proved sufficient
60,
for takeoff with maximum payload
65,
at the highest and hottest of airports.
70,000.
The engines, therefore, are demonstrated at power levels beyond those required in service. The certification authorities ask for a 150-hour endurance test. In this time, the engine repeats 25 cycles of worst-case conditions, representing thousands of hours of actual service flying. Rolls-Royce goes one step further to prove the integrity of its engines, subjecting them to a cyclic test. This replicates the conditions of a typical flight, including reverse thrust, squeezed into just 5 minutes. This cycle is then repeated over 2,000 times, a total of well over 150 hours. All in all, a total of 250 tests. Not just the big, almost glamorous exercises, but tests for every conceivable condition and eventuality. Tests for fire, corrosion, strength, pressure, vibration, noise, integrity, and emissions. Tests for the most conventional of components, such as oil pipes, and for the more sophisticated components, such as FADEC. Tests validating the oils, the instrumentation, and the accessories. 250 reports. More than satisfactory in every detail, but all the details count for nothing if the engine cannot match up to the larger tests, which include bird ingestion and fan blade containment. Others perhaps see these tests as moments that can destroy an engine and its reputation. Rolls-Royce regards them more positively, final proof of the engine's integrity, proof that can be recorded and shown to the world. Proving that an engine can withstand a bird strike during takeoff begins, as ever, with the design process. Here, computer modeling is being used to predict the results of bird impact on a fan blade. A single-arm rig test then confirms the computer analysis. Finally, in the full engine test, birds of specific weights are fired at the engine, aimed at a range of locations on the fan, including the center and the outer quarter. The engine has to prove it could continue takeoff, circle and re-land safely, so demonstrating the integrity of the individual blades and the engine's ability to cope with both the resulting impact and any debris ingested through the core. The unquestioned triumph of the fan blade in these tests is due in no small measure to its unique construction. The Trent wide chord fan blade is diffusion bonded and superplastically formed, processes which no other manufacturer can match and which produce the strongest blade in the world, capable of absorbing the impact of a bird strike with zero material loss. Not just the strongest blade in the world, but also size for size, the lightest, a feature of no little importance when it comes to the fan blade containment test. In this test, a small explosive charge is used to release a fan blade from the disc. The engine has to contain the fan blade safely and also has to contend successfully with the resulting out-of-balance forces. This is a technology in which Rolls-Royce has a clear lead over any other manufacturer. Nevertheless, the fan blade containment test is regarded as an essential demonstration of safety and integrity.
4, 3, 2, 1, fire sequence.
A released fan blade contains enough energy to throw a medium-sized car some 100 feet into the air. In a full engine test, this energy is absorbed as vibration through the engine carcass, truly one of the most impressive sights in aero engine testing. Without any apologies, we'll show that again. This is indeed one of those occasions when only seeing is believing. $250